Hello friends, and today we are coming with new topic that is very important, and that is the projectile motion. But in this one class, definitely we cannot cover all the things. That's why I have started only the basics of projectile motion. Again, you know my name, Harimohan Singh, or you can call HM Sir. Okay, so now we are going to start for projectile motion. But before starting the projectile motion, I'll give you the basics of motion in plane so that you can understand ki how the projectile motion can be considered and what is the projectile motion. So before going to into that part, I'll just tell you the few normal concept of the motion in plane. When motion of plane, if you understand, that would be better to learn to understand the motion in projectile. Okay, let's see. So next we can see this is the motion in plane. I'm just telling you one example by giving, you can check, suppose in a one plane, if velocity, initial velocity is given to you, suppose 2I cap plus 3J cap. This is the one velocity, initial velocity given of any particle, and acceleration is suppose given to you I cap plus 2J cap. Okay, it's a meter per second square. You can take the units, and this is a meter per second. It's the initial velocity, this is the initial acceleration, and acceleration is constant. So now we can understand how to apply the equations here to calculate displacement or to calculate final velocity after few times. So I want to calculate the velocity and displacement covered by the particle after 4 seconds. It's a very basic question I'm just giving you to understand the concept. Okay, so how we can solve? So we already know the equation of motion. So from equation of motion we can say the V equal to U plus AT. We can apply. The second is the, if we are writing, that is equal to R vector, that means delta R actually, displacement vector, that is equal to UT plus half AT square. These two equations we are going to use, and then we can calculate the displacement as well as the final velocity. Okay, let's see how to solve this part. So very first equation, that is V equal to U plus AT. Now put the value. What is the U? U is the 2I cap plus 3J cap plus acceleration is I cap plus 2J cap. Time is 4 seconds. You can multiply. Directly you can say from here V equal to, I can say 6I plus 11J cap. It's the meter per second. It's a very basic calculation you can do. Second is the displacement. So delta R would be UT plus half AT square. So delta R, what is the U? U is again given to you 2I plus 3J, and time is 4 plus 1 by 2, acceleration again I cap plus 2J cap, and time is again 4, so you can use 4 into 4. So from here I'm just doing little bit calculations, you can understand, that is equal to 8I from here, 12J, and from here if you can check, this is the 8I plus 16J, and you can say 16I plus 28J. You can check the calculation. If there is any mistake, you can comment. Okay, it's a basic calculation you can do. So this is the final velocity, this is displacement covered by the particle. This is the one way to solve this question, but there is another way also to see this part, because in the previous chapter we already know the motion in straight line. In motion in straight line we know this equation, but not in vector form. So we can see here there are two directions of motion, one in x direction, one in y direction. That means particle is having velocity in along x direction as well as in y direction. So one is along x direction, along y direction. So why not we are considering there are two different motion, x direction motion separately and y direction motion separately. So we should consider those two motions separately. I want to see that calculation. So for that I'm just writing x direction motion and y direction motion separately. So you can say this is the x motion, x direction motion. In x direction motion. Similarly, I can write here y direction motion. Okay, this is the y direction motion. In x direction motion, you can say, sir, Vx is equal to ux plus ax into t. Vx we want to calculate. What is ux? Ux, if you see from here, it is given to you 2. So you can put the value 2. Acceleration is given to you in x direction, that is the 1. You can choose from here, that is the 1, and time is 4. If you multiply, you will solve. This is 2 plus 4, that is equal to 6 meter per second. This is the Vx. Now, similarly, we can calculate x. X equal to uxt plus half of axt square. When you are putting this thing, you will find x equal to, what is ux? Ux is equal to 2. Ux is equal to 2. You can put value, and time is again 4 seconds. You can put, and 1 by 2. Ax is how much? Ax is 1, and time is again, you can take 4. Now solve it. This become 2. So this become 8 plus 8. Total x is equal to 16 meter. It is how much? 16 meter. You can check it. This is the x direction motion. Similar calculation, if we go for it, you can check here that y direction motion. So you will say here ki sir Vy is equal to uy plus ay into t. Vy we want to calculate. What is uy? Uy you can check from here, that is equal to 3. It is a 3 plus what is the acceleration in a y direction, that is a 2. So you can take 2 into 4. If you multiply, this become 8 plus 3, that is equal to 11 meter per second. This is the y direction. Okay. Similarly, you can do the again displacement y equal to uyt plus half of ayt square. If you say y equal to, what is uy? Uy you can check it. What is uy? Uy again 3. You can choose this. 3 into time is 4 plus 1 by 2. What is ay? Into 2. 2 into 4 square. Now solve it. This become y equal to 12 plus that would be 16. So y equal to 28 meter. This is the another way to solve the same question. Now again you will ask, sir, why you are wasting the time? You are putting the same question by two different methods. One is the vector method, another is the straight line method. Now this is not my concern to solve this question by two different ways. My concern is only here to give you the concept, what is the meaning of motion in plane. Now see here, if you check, this velocity is having two components. Final velocity, that is the 6 in x direction and 11 in y direction. Similarly, you can check here the 6 in x direction and 11 in y direction. Similarly, if you see the displacement, this is 16 in x direction and 28 in y direction. You can check here also 16 in x direction and 28 in y direction. But wait, when I was solving x in second method, I was not looking for the y. When I was solving y, I was not interested in x. What is the meaning of that? Meaning is very simple, that x direction motion and y direction motion, there are two independent motions are there. When two independent motions are clubbed together, we call motion in plane. What we call motion in plane. So similarly, but there can be some restrictions also, there can be some constraint also, because the one particle is moving in two different dimensions. So definitely there would be some constraint. But there are two independent motion. One motion can be affected by another in some way or another way. We will check with the time, but they are two independent. You can see them independently. You can take some constant from one and you can put in another, or you can take constant from second and put on one. That can be possible, but they are two independent in one way. Understood? So these are independent. Now see, what is the projectile motion? Our concern is very simple. What is the projectile motion? So now we are going to start the projectile Now you will understand. In daily life you can see I am having a one ball I am throwing to my friend, that is a projectile. In the second way, when footballer is there, he kick the football, it is going from one place to another place, that is also projectile motion. Any gun is there, from gun the bullet is fired, it is going in some way, that is also projectile. If car is there, it is moving from the cliff and it is going in one path, that is also projectile motion. There are lot of projectile motion we see in our daily life. So these all projectile comes under the basic rules. Certain rules are there, certain equations are there, certain formulas are there, they obey those. So now we are going to drive all those parts one way and try to understand those concepts with a few examples. So we can start now projectile motion. So when we are seeing the projectile motion, you will understand कि suppose here this is the horizontal direction and it is a vertical direction. In vertical direction, one particle is projected from here with the initial velocity u at an angle theta. So this particle reaches from here to here. So this distance in along horizontal we call range. What we call range. Okay, and the maximum distance it covers, if we see here, you can find this is the maximum distance it covers, that we call in vertical direction, that we call maximum height. What we call maximum height. So h we call maximum height. Okay, and when it starts from this point A and it reaches to this point B and then to C. So A to B, this motion, it is ascending motion. What we call it? Ascending motion. Ascending motion. Similarly, you can check this motion is the descending motion. These are few things you have to understand. But this time, here to here, if we see, that we call time of ascent. Here to here we call in descending motion, that's the time of descent. We will understand those things. But listen carefully, again this is the two-dimensional motion plane. In motion plane, just now I told you, definitely it is the combination of two independent motions. That means horizontal as well as vertical. That means the same projectile motion, I can understand one is along x direction, one is along y direction. How can I understand? Listen. I can say this is a combination of, it is a combination of two independent motion. One is horizontal, from it is going from A to C like this. A to C, that is the range. And there would be some velocity, we will check that. And another is the vertical motion. It is a vertical motion. So it is going from here to here, vertical motion. And it is going up to the maximum height of h. And this is the left side is the ascending motion, that is the time of ascent, and right side is the time of descent, that is a very simple thing. Okay, if we go for total time, that we call time of flight. So this is the range, this is the point. Now listen carefully. Again, they are related to the one particle, that means we have to understand their motion one by one in detail. Now focus on the board, you will see what is there. If we are checking here, this velocity u, it can be written the two component. One is along horizontal, that is equal to u cos theta, and this is what beta u sin theta. So there are two components, one is along horizontal and one is along vertical. So along horizontal we are having one velocity, that is equal to u cos theta. If we are talking about vertical, there would be one component we call u sin theta. Along horizontal u cos theta, along vertical u sin theta, these are things. Now one more thing you can say, the acceleration. And we are talking about the acceleration, you can find in a horizontal direction there is no acceleration. In vertical direction there is one acceleration, that is equal to g. So these are few things we have to understand. Now again we can say this is one horizontal motion and the vertical motion. Now we have to understand it is the horizontal motion. Okay beta, and this is vertical motion. It is vertical motion. Now focus on both. You will understand. Now we are writing, the one is a horizontal, one is vertical. So this is the horizontal motion. This is the vertical motion. Okay, now check in the left side, horizontal motion. What are the velocities given to you? I can assume this is the x direction motion, x-axis. Okay, you can write. This is the x-axis, this is the y-axis. I can write. So along x-axis you can write, it is the y-axis you can write. In x direction, when you say what are the velocity, so you can say initial velocity is u cos theta, but x direction acceleration is equal to 0. Similarly, if you go for the vertical motion, you will say the uy is equal to u sin theta. In along vertical direction, the component is u sin theta, and acceleration is equal to minus g. Downward direction I am taking negative, and upward direction we are taking positive. This is a very simple sign convention. I can write here sign convention. It is a positive direction, and vertically downward direction is the negative direction. It's a very simple. It's a sign convention, I am using it. Now focus on this part. It's the moving. Now check in the horizontal motion. In horizontal motion, only the one speed is there, u cos theta. There is no acceleration. That means the particle is moving with the constant speed. Until what time? We can't say. It is moved. So who will decide that the particle will move up to what time? It will decided by vertical motion. Because once particle reach to the ground, again it cannot move. Understanding? It will fall down to the ground. That means here the constant is that the time is decided by vertical motion. They are independent, but they are the one constant that time would be decided by vertical motion. Understanding? So this is the time. So now we have to ask to this vertical motion, what is the time? So very simple thing, you can understand. If the particle is thrown from the ground, it is reaching upward and coming down. What was the initial velocity? You can say u sin theta. Acceleration you already know, at the topmost point velocity is equal to 0. So we can apply the first equation, vy is equal to uy plus ay into t. Final velocity at the topmost point 0. Initial velocity is the u sin theta minus g into time of ascent. So from here time of ascent is equal to u sin theta by g. Directly we can say, and we know from the motion under gravity, if time of ascent and time of descent are equal if there is no air friction. They are equal. If we talk about the what is time of flight, so you will say directly time of ascent plus time of descent. If you add both of them, you will get 2u sin theta divided by g. This is the time of flight. We can find this is the time of flight. It is the time of ascent, time of descent, time of flight we can calculate. If we ask you what is the maximum height attained, so that is also very simple. You can use the third equation, v square is equal to uy square plus 2ayy. Definitely the final velocity at the highest point is 0. So 0 is equal to u sin theta whole square minus 2gh. So from here you can say h is equal to u square sin square theta divided by 2g. It's the maximum height attained by this particle. Okay, now we have to check what is the horizontal range. How to calculate? The particle is moving from here to here, this point A to C, we know that part, and the velocity was u cos theta. Now it is moving with the constant speed, but up to what time? The time of flight is given to you, to u sin theta by z. So I can put that time, that is equal to t. So from here you can say that this range is nothing else, r is equal to u cos theta into t, or you can put the value of time, r is equal to u cos theta bracket to u sin theta divided by z. This becomes u square into sin 2 theta divided by g. I have used one trigonometric equations here. that you can say sine 2 theta is equal to 2 sine theta cos theta. This basic formula I use from the trigonometry. You can check this part. Understood? So these are few rules, few formula what we have derived. Okay. Now I am just adding this, actually collecting this all formula all together so that we can use. So what are the range we have collected? That is equal to u square into sine 2 theta divided by g, or sometime we can say u cos theta into t. Okay, this is the again range formula. Now second is the maximum height, that is equal to u square into sine square theta divided by 2g, or sometime we can say u sine theta whole square divided by 2g. It is also maximum height formula. If we talk about the time of ascent, time of descent, that is equal to u sine theta divided by g. It's a very basic equation, we can write it. And similarly, time of flight is equal to 2u sine theta by g. It's a basic question. Now another question comes to you here. What is the meaning of this projectile? Now suppose this particle, I told you in the vertical motion, it reaches to the highest point and coming back. When it is coming back, the question again remains same. What is this velocity? So you know the here highest point, this velocity is 0. So now this is descending motion, we are checking it. So for descending motion, if you check it, so what is the velocity? So again you can apply here, because time we already know, time of descent, that is equal to u sine theta by j. So from that you can write what is its value. That means Vy is equal to u, just wait, Vy is equal to uy plus ay into t, we can write. Vy we want to calculate. What is uy? Here the highest point 0 and acceleration is minus g, downward direction negative, and time we already know, that is equal to u sine theta by g. So you can say u sine theta by g. That means g can be removed. That means Vy is nothing else minus u sine theta. That means vertical velocity at the point of landing is same, only direction is opposite. Initial was u sine theta, now point of landing this is the minus u sine theta. The same value but in opposite direction. We can, by our motion under gravity part also, we can understand this basic thing. Now understand one more thing. Suppose this was the projectile motion. In this projectile motion, what we are understanding, this is the u, that angle is theta, the particle is going like this. It's the x-axis and this is the y-axis, or you can say horizontal. Okay, it's the horizontal and it is a vertical. Okay, it's a vertical. This is a very basic thing. Now focus on this board, you will understand that this particle is moving here to here. So what are the things we understood till now, that thing we have to focus. Very first thing, horizontal velocity is u cos theta, vertical velocity is u sin theta. But in horizontal direction velocity remains same, because acceleration is 0. That means any point of time you will find this velocity would be same. Any point of time you will find the velocity is same. How much? U cos theta. U cos theta. Any point of time you will find this, the u cos theta. It's the u cos theta. This is a very basic thing. Now understand one more thing. At highest point, we already know the vertical velocity is 0. That means at highest point only one velocity present. What is that? U cos theta. And this is the minimum speed in the projectile motion. Now when particle is moving on this projectile, at the highest point its speed would be minimum. Its speed would be minimum. Why? Because vertical becomes 0. At other than this highest point, all other points there would be some value of vertical. But at highest point, at vertical component would be 0, only horizontal present. That means that would be minimum value. So at highest point you can write is the minimum value, and that value is equal to V cos theta. It's a value, very basic thing. And horizontal component remains same. Horizontal component of velocity is equal to U cos theta, and that is constant. This thing we have understood from this basic calculations. Two things. Now come to the third point. You have to be focused upon it. When we see the point of landing, there the one component is U cos theta, another component is U sin theta. Just we have derived U sin theta. It is similar. U cos theta, U sin theta, here U cos theta, U sin theta. That means here also this final total net velocity will be U only. That is the U only. That means this angle of projection is theta, then point projection, this point of landing also would be theta. That is also with the horizontal, same angle, that would be theta. There is no change about it. That thing you have to understand first. Clear? So up to here we understood basics of the projectile motion. Okay, at highest point, what is the its velocity, what is the its horizontal component, what is vertical component. You understand this part. Listen, this same question can be asked in different manner. Let's focus. They can ask you where the kinetic energy minimum. Kinetic energy minimum means speed should be minimum. Speed would be minimum where? At the highest point. This is the one P by Q. Second P by Q, they can ask you where the potential energy maximum. We know the potential energy maximum at the highest point. They can ask you the ratio. What is the kinetic energy to the potential energy ratio? We can do it. We will solve that type of problem. Very basic questions are there. We have to focus on that. Similarly, they can ask you the change in momentum from one point to another point. So change in momentum we know that is equal to how much? Force into time interval, F into delta t. So change in delta P is equal to F into delta t. So force we know here, what is force acting? That the mg. That is a constant force, always vertically downward. And whatever the time interval given, multiply that, you will get what beta? Change in momentum. If we know change in momentum, accordingly we can find change in kinetic energy. This type of basic question that can be asked. Okay, some more basic, very basic question if we talk about, we will see little later. This is the first example. Focus on the board. A ball is thrown vertically upward with the at an angle of 53 with the horizontal with initial speed of 20 meter per second. Calculate time of flight, maximum height attained and range. It's the first question. Now we have to understand what is the question. Focus. What we have learned, the same formula we have to apply here. This angle is given to you 53 degree. Okay, this particle is going from here to here. Now we have to calculate its range. We have to calculate its maximum height and time of flight. So very simple. This is 20 meter per second. So what is the formulas? You can apply directly. Time is equal to 2u sin theta by z. 2u. U is 20. Sin 53 degree. You can say sin 53 degree. Divide by g. I can take for simplicity that 10. So I am taking the value of g is equal to 10 meter per second square. Okay. Directly we can apply this part here. Now solve it. What you are getting, you will get from here that 10, this is cancelled. Sin 53 is a 4 by 5. So t is equal to 4 into 4 by 5. That means this becomes 16 by 5, or you can say 3.2 second. It's the time of flight. Now, second question comes to you. What is its range? So when you say the range is equal to u cos theta into t. I told you. What is the u? You already know 20 cos 53 degree multiplied by time. Time is again you know 16 by 5 or 3.2 you can use. That is equal to 20. What is the cos 53? That is equal to 3 by 5 into 16 by 5. From 5 this become 4 and just multiply this. 12 into 16 divided by 5. So that value would be 192 by 5, that is equal to 3, and 8.4, that is equal to meter. That's the range. We can calculate this part. Okay. Now another part, you can calculate from here what is the maximum height. What is the maximum height? That is equal to u square sine square theta divided by 2g. What is u? Again you can put the value, that is 20 into 20 cos 53. I can put the directly value, that is the 4 by 5 and upon 2 into 10. So 2 into 10, 20, this is cancelled. From 5 this becomes 4. Just multiply the values, that would be 64 by 5, that value 12.8 watt meter. This is the basic calculation you can do. This is the first part of this question. Now focus on the second part, the velocity at the highest point. So I told you the velocity at the highest point, only one component, that is the u cos theta. So second part is nothing else, velocity at highest point, that is equal to u cos theta. How much? You can put the value, u is how much? 20, cos 53, that is equal to 3 by 5. From 5 this would be 4, so that means 12 meter per second. So at the highest point the velocity is the 12 meter per second, you can calculate. Next is the ratio of potential energy to the kinetic energy. Ratio of potential energy to the kinetic energy. How to calculate that part? Try to understand. When we are going to write the ratio, so you will say the potential energy divided by kinetic energy. When we say potential energy, how much? So you will say mg capital H. What is the kinetic energy at the highest point? You will say half m. But highest point velocity we already know, u cos theta. So you can say u cos theta whole square. Now m can be removed definitely from here. You can say 2g. H is how much? You can say u square sine square theta divided by 2g upon, this would be u square and cos square theta. M we have already removed from here. So what you can see, u square can be cancelled, 2g also cancelled. So that become potential energy to the kinetic energy, that is equal to 10 square theta. Very important result. Directly you can apply in any question. Okay, tan theta, theta is already given to you 53. You can put the value. What is the value of 53? Tan 53 is nothing else, 4 by 3 whole square, that would be 16 by 9. That's the answer. Understood? So how to apply the different formulas here, you have to understand. Okay, this is the first question. Now we can move to the next example. You will learn that also. Very first, a ball is thrown upward at an angle of 60 degree with the horizontal and with initial speed of 40 meter per second. Initial speed is given to you 40 meter per second. Calculate time after which its velocity vector makes an angle of 30 degree with the horizontal. We know that part, with the time that angle is going to change. So we have to calculate that time, and the time after which its velocity would be normal to the initial velocity. Both are very good question. You have to focus, and that type of question you can find in the previous year. Okay, so I am taking first question first. Very first, you will say, first picture, this is the initial velocity. Okay, this is u. This angle was given to you 60 degree. It is going like this. After some time, this velocity makes an angle, how much? That is equal to 30 degree. Or I can assume this velocity is v. But we know one thing here, that here initial component was how much? U cos 60 degree. Here v cos 30 degree. But what is not going to change? Horizontal component is not going to change. That means you can say v cos 30 degree is equal to u cos 60 degree. What are the values? We have to calculate cos 30. Cos 30 is nothing else, root 3 by 2. What is u? U already given to you 40. You can put the value 40, and here cos 60 is equal to 1 by 2. 2 cancel. That means from here you can tell that the velocity at that instant is nothing else 40 by root 3 meter per second. We can calculate. Very basic. Now we know the velocity at this point of time. This is. But for time, I already told you in the starting, in the calculation, what is happening? Time is always calculated from vertical motion. Horizontal motion does not tell the time. Why it is not telling? Because speed is constant. That is not changing. Velocity is not changing in horizontal direction. Only vertical direction changing, so that can give you the time. Okay. So now we are going to write the vertical direction component. So you can say initial was how much? U sin 30, and this would be V sin 30 degree. Okay, so I'm applying here for vertical. Vy is equal to uy plus ay into t. What is Vy? Vy is nothing else. V sin 30 degree is equal to uy. Uy is nothing else. How much? U sin 60 degree minus g into t. So from here we can calculate. I am taking gt this side. So gt is equal to u sin 60 minus v sin 30 degree. Now put the values. This is 10 into t. U is for t meter per second, correct? And sin 60 is root 3 by 2 minus v is 40 by root 3 and multiplied by 1 by 2. We can write like this. So very first thing you can do, you can take 10 common. From 2 you can divide, that become 2, and from 2 this become 2 again. So you can say t is equal to 2 root 3 minus 2 by root 3. You can write like this, or you want to change little bit also, you can solve it. This become under root 3 and that would be 6 minus 2. That means from here you can say the time would be nothing else 4 by root 3 second. It's the first question that you can calculate. The time after which it becomes 30 degree with the horizontal. Very first question. Now second question comes to you, the time after which its velocity would be normal to the initial velocity. Very good question. Now we are going to start this question. I am taking to the next page. That would be better to understand. Okay. Now see here. This is a u and this angle is given to you, suppose theta, and it is going like this. So after some time you will see this is the initial velocity, and after some time this velocity vector somewhere here is become perpendicular to the initial velocity. So this is a component you can find. This question can be solved in many ways. I am just telling you one way. Okay, out of that how we can solve it. So try to understand how to solve. Now we can write very basic thing. You can take the components. This is a u cos theta and this component would be u sin theta. Okay, here also you can assume some velocity. This is v, we don't know, and this component also you can take, but listen carefully. If you understand this part, if I extend this line here, so this become a right angle triangle. It's become right angle triangle. This angle is theta, this is 90 degree, so definitely this would be 90 minus theta. If it is 90 minus theta, this would be theta. That means I can say here this v sin theta and this is a v cos theta. We can write this is a v sin theta, this is a v cos theta, but we know the horizontal component does not change. Horizontal component does not change. We can say the v sin theta is equal to u cos theta. That remains same, that is not going to change. So we can say v is equal to u cos theta divided by sin theta. Okay, so this is a very basic. We can find this part, that's the u, v value, and we know v, then again we can apply the vertical motion and we can calculate the time. Again you can say vy is equal to uy plus ay into t. So what was the vy? Vy is nothing else v cos theta but negative. That's the v cos theta. And what is the uy? Uy is the u sin theta minus g into t. Now I can put this value. What is the v value beta from here? You can say this is a u cos theta divided by sin theta. This is the v value and this is cos theta. okay, and here this is u sin theta minus g into t. I am taking g into t one side. Now you can solve from here. That is equal to gt is equal to u sin theta plus u cos square theta divided by sin theta, or you can write little more thing. This is sin theta u sin square theta plus u cos square theta is equal to g into t. So you can take u common, this is u common, this would be sin square theta plus cos square theta divided by g sin theta. Sin square theta plus cos square theta, that is equal to 1. We know that part. So from here you can say g into t is equal to u by sin theta, and very basic thing you can say t is equal to u by g sin theta. Okay, so we have seen a few examples. So for now we can understand that this is a sufficient number of examples. When you come join to us, there you will find a lot of examples, or in some other class we can discuss more. Okay, thank you so much.